All right, so we have notes 2.2, which is just extra practice talking about linear, exponential, and discrete and continuous, right? So this is just more practice at understanding all four of those terms. So discrete, as you can see here, is change that happens all at once. It's like an instantaneous change. So it happens one time a week, one time a month. You know, you get paid one time a week, one time or every 2 weeks. There is no data between the points, so that's super important as well. And then lastly, the most important thing that we talked about was that data is countable. It's continuous if there's change happening throughout the month or the week or years, hours, however. And this data is usually measurable. And what happens is there is data that can be found in between the points, right? So let's look at a graph for a for a discrete. I'm going to use a linear graph for this one. And what happens is we just have dots when it's discrete. So I want you to write that little love note. Dots equals discrete. Okay? And again, this is a linear one. Now, if it's continuous, we'll have dots again. But what's going to happen is we will connect those dots. So this is an exponential graph. So if they're connected, it's going to be continuous, right? Some alliteration for you there. I think that's the word. And then an example of a discrete is earning $10 every week, picking 5 tomatoes from your garden every day. A continuous is an example of earning 10% interest throughout the month. The growth of said tomatoes, right? Tomatoes don't spontaneously end up this big, right? They kind of slowly get to that big. All right. So looking at this first example, the Thornton Township High School Library is the largest collection in Harvey. They often receive boxes of books to be added to their collection. Since the books can be extra heavy, they aren't shipped in big boxes. On average, each box contains about 8 books. How many books are received by the library in 6 boxes, 10 boxes, X boxes? So let's look at this graph here. After 1 box, we're going to have 8 books, which means after 2 boxes, we're going to have 16 books. 3 boxes, we are going to have 24 books, and then 4 boxes, we're going to have 32 books. So what we're doing is, as we go down our table, we are adding by 8. You can also think of this as 1 times 8 gives us 8, 2 times 8 gives us 16, and so on and so forth. The number of books lines up with the number of boxes. So if we have 6 boxes of books, that's going to give us 48. Why, Miss Robwolf? Well, think about this. 6 boxes with 8 books is 6 times 8. So 10 boxes of books is going to be 80 books because, again, we're going to have 10 boxes of 8. So 10 times 8 gives us 80. Now we're going to graph this guy. Some guesstimation is going to have to happen here, right? So let's do this in a different color. So 1 and 8. So I go from the original origin to the 1 up to where I think 8 is. And again, guesstimation is going to be your friend here. So this is where that point is. 16. So from my origin, I'm going to go to the right 2 up to where I think 16 is. Next up, we have 3. So we did 2 and 16. So we have 3 and 24. 3 and 24 is going to be about right here. Then we have 4 and 32. That's going to be about right here. Okay, so we're adding down our table, which means we should have a straight line. And when we look at our dots as they are on our graph here, they do make a straight line. That's good. We have been correct. So first we got to talk about unpacking books. Is that a continuous thing or a discrete thing? Do you count the number of books that you pull out of those boxes, or do you measure the number of books? you count them, right? So this is because we are counting books. This is a linear equation because we are adding by 8 down our table. Also, our graph is a straight line, which is another indicator. Now, the equation is going to throw some of us off just a smidge here. So, we're making a y equals equation, right? What math are we doing down our table? We are adding by 8. Now, this represents adding by 8, even though there's no plus sign there. Because this is a positive 8, it represents adding by 8. Now, what we are doing down a table always gets the x value attached to it, okay? But we have to be careful. Think back to arithmetic. We have to do x minus 1 here because look at this. We start with 1 box, not 0 boxes, okay? Then lastly, we have to write this 8 that we started with as plus 8, right? It's a positive 8 up here, so I have to show that it's positive down here. And that's why we write the plus 8, okay? All right, and this is the equation, right? This is just like arithmetic, what we did back in the day. Remember when we had f of n, but instead we would have done 8 plus 8 times n minus 1. These are the same. These are equivalent, which means they are equal. We just flippy-flopped. They're the same, but flipped, as a student said. Okay, they're the same, but flipped. So now I'm going to just get you started on the rest of these. So many of the books at Thornton are electronic. If about 13 ebooks can be downloaded onto a computer each hour, how many ebooks are there going to be in 3 hours, 5 hours, X hours? So I'm going to help you get started. Every hour, we are going to have 13 books. So on the second hour, we should have 26, which means going down our table, we are adding by 13. So why don't you pause the video, and I want you to try the rest of this problem on your own and see how you do. Please make sure you do it in pencil so you don't make any silly sign mistakes or anything, okay? All right, again, these are your notes, so make sure you got everything because you can use your notes on quizzes. All right, hopefully the rest of your table looks like mine. So at 3 hours, there's 39 books. At 4 hours, there's 52 books. So 39 books after 3 hours. After 5 hours, we have 65 books. Here's the graph that goes with our table. Again, I did guesstimation for each of those points. Best estimate guesstimation. Now, this is a continuous thing because if I have a download bar here, right, it doesn't suddenly fill up. It slowly will start to fill up, which is a continuous thing, okay? So that means when I graph this guy, I have to have a connecting set of dots, so connection. That's not the greatest straight line, but you get what I'm trying to say. And then it's linear because we were adding by 13, and our equation is y is equal to 13 parentheses x minus 1 close parentheses plus 13. This plus 13 is the number we started with, how many books we started with. This 13 here is the 13 we are adding by down our table. I also know that it's the 13 I'm adding by down my table because it's right up here next to the x. They are partners. They are next to each other. So that is a good indicator to me that 13 is what we do down our table. And then it's x minus 1 here because we started at time 1. Okay? All right. Librarians work to keep the library in order, so they put the books back on their proper places after they have been used. They can sort and shelve 3 books per minute. How many books does the library take care of in 3 minutes, 5 minutes, and X minutes? Again, typo as per usual. So they should all be minutes. Try not, if you want to figure out the hours, you're more than welcome, but my answers are going to be in minutes. So, we have every minute they have 3 books. So, every 1 minute they have 3 books. So, at 2 minutes, that means they're going to have 6 books, which means we are adding by 3 down our table. Again, go forth and finish the rest of this. See if you get the same thing as me. Again, remember, pause the video, see if you get the same thing. All right, hopefully your table looks the same as mine. This is what happens when you add by 3. So at 3 minutes, there were 9 books. 5 minutes, there were 15 books. Here's the graph. It's a very itty-bitty, teeny-weeny graph, which is nice, I guess. And then this is a discrete because you're putting books on the shelf. You count how many books you are putting on the shelf. And then this is linear because we are adding by 3. Also, our graph makes a beautiful straight line. And then our equation is y is equal to 3, because that's what we do now on our table, times x minus 1, because we start at time 1, and then plus 3, because we started with 3 books. All right, looking at 4. So we have a giant piece of paper that is cut into 3 equal pieces. So before there were any cuts, this was our giant piece of paper. So we had 0 cuts. With the first cut, it said we took it and we cut it into 3 different pieces. And then on the second cut, we had to cut those 3 equal pieces into 3 equal pieces. So 3 equal pieces into 3 equal pieces. So here we had 1 piece of paper, then we had 3 pieces of paper, then we had 9 pieces of paper. So with 0 cuts, we had 1 piece of paper. 1 set of cuts, we had 3 pieces of paper. 2 cuts, we had 9 pieces of paper. So this math, don't do plus 2, because 3 plus 2 doesn't give us 9. No, no, no. This is going to be a multiplying problem. So we are going to multiply by 3. Let's see if you remember how to write equations, explicit equations, because that's what we're really writing, our explicit equations for geometric. All right, everyone. Pause the video, give it a go. All right, so here's how your table should look if you multiplied by 3 down your table. At 3 hours, we had 27. At 5 hours, we had 243. When you graph, it should look something like this. You should only be able to do the first 3 dots here, because after that, it has 327. Well, we can't graph to 27 because our graph only goes up to 20. Now, this is a discrete thing because we count the pieces of paper. We count the pieces of paper. This is an exponential equation because we are multiplying by 3. And when we write the equation, we keep it the same as how we did with geometric, right? We write what we started with. How many pieces of paper did we start with? We started with 1. Then we multiplied by 3 down our table. Here I'm going to start using a parentheses to represent multiplication. Don't use your x when you show multiplication anymore because that's going to be kind of confusing with this little x up here. So don't be doing that, right? We're going to take it up a notch. We're going to write it high school style. And then I have just an x in my exponent because we started at time 0. And the reason why we have an exponent x is because we are multiplying down our table, okay? All right, last one. So we're going to do this one all together because it does get confusing for some people, and that's okay. So Miss Rowell had to give her son a dose of medicine that was 60 milligrams. The medicine in little Axel leaves his system 20% per hour. How much medicine will be in his system after 3 hours, 4.25 hours, and X hours? And Miss Rowell didn't adjust her notes for those. So this is going to be a decrease percent problem. So this is going to be a decrease percent, which means we take 100% of the medicine he has in his system every hour and take off, which is subtract, 20%. This leaves us with 80% of the medicine he has in his body. However, we cannot multiply 80% on our table because then our numbers get too big. If it's lessening, he's got to slowly get less and less in his system. So we have to change this to a fancy decimal, which gives us 0.80. And again, anytime you see a percent, you must multiply by 80% or 0.80 as a decimal down your table. Now, Axel started with 60 milligrams of medicine. And if I give that to him right away, how many hours have passed? Well, I gave it to him right away, so 0 hours have passed. But after 1 hour, he's got 48 milligrams in his body. How did I get that? 60 times 0.8. After 2, there was 38.4 milligrams of medicine. Then after 3 hours, there was 30.72 milligrams of medicine in his body. After 4 hours, there was 24.576 milligrams in his body. Whoop. And then after 3 hours, we already figured that out, that was 30.72. Then for 5 hours, so let me write that out, 30.72. Then after 5 hours, there's 19.6608 milligrams in his body, right? Ugly decimals, but all we're doing is we're taking this 80 and multiplying it down our table. We are good at that. We have done that. We have been doing that. Don't freak out because we're working with a decimal. When we graph this, well, at time 0, we started with 60. Then we had 1 and 48. Let me get a little bit closer. Then we had 2 and 38.4. So guessing is going to be your friend with this graph. Then we had 3 and 30.72. Make sure when you guess, it is a good guesstimation. Don't just go all willy-nilly. And then at 4, we had 24.57, which is about right here. Now, medicine in your body as it leaves, it doesn't just suddenly leave. This is a continuous thing, which means I am going to draw a line to connect my dots. And this line is kind of curving as we go down, which means it's continuous, right? Because we measure the amount of medicine that's left in our body. This is exponential because we multiplied 0.80 down our table. Then the equation, you guys should be able to write this, was y equals, we started with 60 milligrams in his body. We multiplied 0.80 down our table, and we did that X amount of times. So I have just an exponent X because, again, this time we started at time 0, so just an exponent X. So this was all of our notes. We have a homework 2.2, which was on paper. There's also a digital copy of the paper version on your Google Classroom if you didn't get it or left it at home or whatever the case may be. Please make sure to use Cami if you're at home to do your homework, and that way you can turn it in and get all that done on time. All right, everyone, have a wonderful day, wonderful rest of your evening, whatever the case may be, and I'll see you next time.